Hi, everybody, and welcome to another webinar. We're so excited today we'll focus on the digital tools and get to show you more of what the digital tools actually look like. We do have a change in the order of the program, and apologies for any background noise that you hear with sirens or anything like that. So Shervin had an emergency at SISK, a meeting that he had to, it was obviously a priority in terms of getting work done. So we will have only 3 speakers. Hold on one second. We will only have 3 speakers, and then out of those 3 speakers, we'll create a unified dialogue, so we'll have more time for Q&A, which is the advantage of that. What we're going to do in the beginning to set the stage is share a video that will ground us in how we're going to go about thinking, and it's from RIBCCS, and where Fred Pichari is representing, and we hope that it'll give you a little more context instead of just having these abstract talks about what digital tools are and how they can be used in the construction industry.
This is our planet. This is us. These are the places where we live, work, learn, produce things, and entertain. We have a name for these places: buildings. While buildings house the world's 7.9 billion population, do we really know the industry we interact with every day? While $94 trillion in infrastructure investment is needed in the next 20 years alone, traditional construction methods cause tremendous waste and a huge carbon footprint. 38% of global annual carbon dioxide is produced by the architecture, engineering and construction industry, which means 19 gigatons of CO2 needs to be reduced through joint effort. While the AEC industry employs 7% of the world's working population and contributes 13% of global GDP, the biggest industry is also the least digitalized one. As a result, 30% of rework performed by construction companies leads to 6 gigatons of unnecessary carbon emission damage to our Earth. We must change the status quo towards decarbonization led by digital transformation. M2 connects all stakeholders, processes, and data along the AEC industry value chain. From supply chain, planning, construction, to maintenance, M2 supports decarbonization throughout the building life cycle. Before a project's physical construction, M2 runs a detailed 6D building information modeling virtual simulation, connecting the 3D BIM model with 4D time factor, 5D cost information, and 6D carbon factor, so that stakeholders can optimize the design, schedule, and carbon emission while reducing rework and the waste of CO2-intensive building materials. As clean energy is being increasingly adopted by the AEC industry, M2 also connects their smart devices to further optimize energy use. By improving site logistics, supply chain, and business partner management with M2, the environmental impact of on-site activities can also be reduced, and CO2-intensive material waste can be kept to a minimum. Business partners that meet the green building standards will be connected to the platform, empowering building projects to achieve the best carbon footprint outcome. RIB and RIBCCS are teaming up to support large enterprises and SME in the industry and their related supply chain with cloud, software platform, and consulting services to roll out M2 to the African market. Sustainable building investment represents one of the biggest global investment opportunities of the next decade, with an estimated 24.6 trillion by 2030. 1% reduction in construction costs could save $100 billion globally. M2 helps construction projects achieve up to 30% overall savings, resulting in 6 gigatons of reduction in carbon dioxide. The M2 construction digital twin data will be the most valuable asset for the next level of decarbonization. From reducing carbon emissions in the midterm to achieving net zero as the goal, M2 supports the AEC ecosystem. Running together, we build a net zero future for the next generation.
And with that, we'll now have Fred join us. Fred is representing RIBCCS, and Fred Pitari, he's a quantity surveyor by training. And one of the reasons that the lineup of speakers that we have today is to be able, everybody asks, only agriculture happens in Africa. So we're here to show that there are other things and there's high technology going on in Africa. And with that, welcome, Fred. I think you're on mute, Fred. Try again. I still can't hear you. And just so everybody knows, we did do a sound check. We heard him when he logged in. Go ahead, try. I don't know what's going on. You want to try your sound? Oh, okay. Maybe switch out, and Carolina is saying try your computer settings. I think I see him fiddling with things. Maybe log out and log back in again.
Is that any better?
Perfect.
Fantastic. Good stuff.
So with that, I'll hand it over to you, and welcome, Fred.
Thank you, Cecilia, and the rest of the team. I'm very grateful for the opportunity to talk to everyone about how we can use digitalization to lessen the impacts on the environment. All right. So I'll be sharing my screen in a bit. So I'll just basically give a brief introduction of who I am and the company that I represent, and then now we'll get into it. All right. Right, so I am QS Fred Allan Kitare, has been introduced by Cecilia, our host. And yes, I'm getting a bit of echo, so maybe just adjust that. But yes, I am Kiosrada Lakichari. I am the Candy Technical Consultant for RIBCCS. I am currently in charge of the East African region. Yeah, and I look after every client who falls in this region. And yes, we will be looking more into our role in this region. But just as a background, RIBCCS has about 40 years industries in experience, and we're in about 80 countries with thousands of users worldwide. We pride ourselves in having a fit-for-purpose integrated solution with unrivaled industry specialist support. That's because everyone who is in RIBCCS is our team is constituted of people who are industry experienced. So we have engineers, and we also have quantity surveyors such as myself, and we also have research and development that has enabled us to catch on over the years. Right, just as a representation of our global presence, we have our offices around Africa, in Australia, in India, in the UK, in the US, and in South America as well. Some of the industries that we operate in, such as in building, civils, and marine and infrastructure, mining, and power and energy. This is because of our vast portfolio of clients and also a vast portfolio of projects that fall in this category. Of course, built for the construction industry and the various players in that, such as the estimators and business owners, and contractors, project managers, and even IT leaders and executive. It's just to give an indication that even all the research that we present in this session has come from somewhere. Yeah. Right. Yeah. So we also have a series of projects and case studies that have previously been completed and have used this backdrop of having a fully digitalized system that takes into consideration, how you plan your resources, and using the 3D models, of course, taking into consideration sustainability as the end goal. And just to move on. I'm not sure if I'm still presenting.
Stop.
All right, apologies for that. Of course, as I had previously shared, is that we have a number of projects that we are proud of to be associated with, and through the experience of all these projects that have, used this platform of digitized construction and digitized solutions, we have definitely come face to face with very many challenges when it comes to managing our construction sites. And the thing that we note is that problems arise across all stages of the project life cycle. For those people who have been experienced in project management, you realize that there's very many problems that arise, such as wastage and a lack of proper management of your resources across the project life cycle. And definitely small discrepancies can have, happening over a long period of time can have a huge impact. And to just bring this ship to land is that if you look at some of the aspects that are involved in construction, such as resource utilization, you may find that, yes, you may have, because of lack of proper use of resources, proper utilization of resources, you may have a lot of rework that you need to do in terms of the construction processes. And this definitely leads to more wastage in terms of your processes. This then results in a bigger carbon footprint, being inflicted on the environment. And definitely, even from what we have researched and what we have seen, is that about 30 to 40% of all greenhouse emissions are attributed to the architecture, engineering, and construction industry. And this is because the choice of materials that we use in all construction processes impact on the carbon footprint of your specific project. And we also have energy production for buildings, which also lead to use of methods that continually harm the environment, and also in terms of providing heating and cooling for buildings, and definitely management of waste during the construction process, and also management of waste from construction and buildings. All these factors contribute to about 30 to 40% of total emissions, which really is a huge number if we were to look at it in terms of the impact. And I don't think this is something that can be let to slide, because if we're looking at a sustainable construction industry, we need to be able to call ourselves to accountability and ask ourselves, okay, we have been doing these things for years on end, and we know that this is the impact of these processes, in our daily site activities. So then, where does our responsibility lie as players within the industry in terms of rectifying and trying to reduce the impact that our processes have on the environment? Of course, there's some questions that we need to ask ourselves, like, where was the actual point of departure? Where did the rain start beating us? And as I look at it from a project management point of view, we have cases of a lack of concise information as regards the resource requirement for projects. You find that we have an over exploitation of resources that definitely leads to generation of more wastage than is necessary, which of course as a result has a rollover effect on the environment in terms of production of waste. And then also lapses in the management of the value chain, that is from manufacturers till the end users of the building. We are definitely not managing all these processes as seamlessly as they need to, because we find that there's very many things that slip into the cracks. We find that if we're not properly managing our plant and equipment, to optimize usage and resource consumption, we find that there's a lot more that is consumed. There's a lot more that leads to losses, and also there's a lot more that leads to a negative impact in terms of the overall effect on greenhouse emissions and the carbon footprint onto the environment. So then really, once we have asked ourselves these questions, we then need to ask ourselves what would be the most possible and most plausible steps forward. In this case, we then find that we are in a jumbled mess where we have unstructured data. We have very many data silos, and we also have very many disconnected and disjointed processes that all come together in an attempt to build up what we know as the construction industry. And then we want to now have a more connected, a more structured way of handling all these processes, which now will give us at least attempt to give us a closer handle in terms of managing these processes. And that's why we like we're trying to quote unquote preach this gospel of digitization, which will assist us in definitely managing our processes a bit better. And just to give you an idea of what successful decarbonization, if I can call it that, would require, and that would definitely mean it would require connected data, connected and structured data, and this, of course, takes the shape of a 6D approach, of which we have the 3D building information model, where we have all the designers coming together to create a digital twin of the actual construction project, where we can be able now to simulate many factors around the design to optimize the design such that it reduces the impact on the environment. Of course, now we'll take into consideration the time factor, which is what we're calling the fourth dimension. And the fifth dimension will be the cost information. Of course, now, because we have put every other aspect into consideration, we now will want to know how it impacts cost and if that makes financial sense. And of course, the sixth dimension being sustainability, where we look at various ways in which energy can be properly utilized within that building and within that construction project. If we can make use of sustainable means of recycling energy and making that space a bit more habitable, of course, while still considering the other factors of cost and time in the design. And basically, that's what we look at in a nutshell. We call it enterprise efficiency, where we have various components and aspects of a digitized solution from RIBCCS that allows you to estimate and control the built environment projects in terms of building up your estimates. You'll be able to bring all that disjointed information in terms of the designs and your construction processes, and you align all these items into an environment where you can be able to manipulate all this data to be able to now see how each of it interplays. We then give you a feature where you can now manage the processes, like I was explaining before, in terms of your site procedures. You can do your plant management, to make sure that the amount of diesel, for example, that is being used is only optimal, of course, because we also know that these heavy plant and equipment also have a huge impact when it comes to total emissions. And then we also now allow you to collaborate on site, and really what this means is that the entire team can be connected on their devices to optimize on your site logistics. You can manage your business partners and also be able to manage your supply chain, and also be able to just monitor, because now you're now managing everything on a resource level. you can also be able to accurately monitor and assess the environmental impact of the various processes. And then, of course, once consumption has been controlled and you know exactly what the resource requirement is for your project, you can then now be able to reduce and optimize, in terms of the CO2 intensive materials that you need on your site, which is quite good because it now gives you the ability to also now have various analytics and dashboards that can be able now to take all that information that you fed in, in terms of connecting. That you say that this is the resource requirement for this project. This is the programmed or the projected outlook, the projected consumption, and it can now give you, the projected impact on your on the environment of your project. And this is basically what we're talking about, straight from the very start of the project until the very end, where you have your project complete. So what basically we are trying to push towards is a solution where every aspect of the construction process has been, accounted for, and where where there's lapses, you can be able to quickly identify those, as opposed to being in a traditional setting where things do not really add up. You may not be able to know the impact of something, of a certain process until it's a little bit too late for you to make any changes. But you see now, because we are starting to create a digital twin, which allows you to take into consideration all these factors, right from the start of the project until the very end of the project. We're talking about managing your 2D takeoffs, and then now feeding that into all the other aspects of estimating, planning, forecasting, doing your cash flows valuations, and cost and allowables. So basically, we're trying to look at a solution that will, of course, give you an increased accuracy and control, and even visibility when, by the time you're preparing your estimates, you can be able to project till the end of the project. And of course, we will be at a stage where we can combine very many features to eliminate the departmental silos where there's disjointed coordination on site. And then, of course, to minimize things like manual processes and errors, that may arise from the construction process, just to be, to enable us to move to a stage where we can, to manage, of course, constructions and the likes, of course, and can be used by small, medium, and large entities as well. Cool. So I'll just mention briefly what this will also entail, that you can be able to have support and training from our side. And of course, if you ever need any further assistance as well, then this can also always be given to you. And of course, now, because we have a full solution, you can also be able to have real-time data and manage your costs accurately. Of course, have better project management control, better collaboration and transparency. And basically, we're looking at how we can also build this the business and the profit margins for the all the users of this solution. And of course, you can be able to make more informed decisions at the end of it. So basically, in a nutshell, we are preaching the gospel of digitizing so that we can be able to control these processes. Yeah, because we want to have a greater and a more closer control in terms of how we design our buildings, in terms of their overall environmental impact. And then, of course, because we have broken down every element into the resource requirement, we can also be able to substitute, in a situation where we have seen that a certain building material has quite the negative impact because of the volumes that are required, then we can be able to now easily substitute and say, because we already know the exact resource requirement of that resource totally in the entire project, then we can be able to say that, okay, fine, if we substitute this, then we have assessed the impact that it may have in terms of emissions, and you can be able to make that decision very easily, as opposed to making decisions in the dark. Right. So with that, I would like to pause and end my presentation there. Of course, it's been very brief, but I hope that it has shed a bit more light in terms of how we can be able to manage these construction processes, and that we'll be able to see how we can be better and more accountable and more responsible in how we carry out our construction processes. All right, Cecilia, back to you. Thanks.
Thanks, Fred. That was great. And key takeaways are we need to start collecting our data, everything that's in paper form, put it into the digital space, and the ways in which errors lead to increased cost accounting. I see we have a quick question. We want to hold questions until the end, but this is a quick, probably yes or no question. Can the RIBCCS tools be used for facilities management instead of just construction?
Absolutely, yes. There's ways in which these tools can be extended into facilities management, and yeah, we can. I'll be glad to pick up a call with CK, so we'll be able to see how that can be utilized.
Great. And overall, then we'll get into the Q&A with more details that flesh out what Fred has said. For now, we want to move on to Ean Mikale, who is with Infinite 8 Industries. And Ian has the background in terms of actually setting up these digital twin models, whether it's in the Omniverse space or in the metaverse space. So welcome, Ian. Thank you.
All right, thank you. Can you hear me?
Yes, we can, loud and clear.
Okay, so I'm gonna go ahead and share my screen. All right. All right, so thank you guys for having me. My name is Ean Mikale, and I'm the founder and principal engineer of Infinite 8 Industries. And we specialize in industrial artificial intelligence as well as Web 3.0. And today we're going to talk about the metaverse, which a lot of you have probably heard about. There's a lot of hype behind it. We're going to dig into what that really is and what it means for the construction and architectural industries in regards to digital twins. And so in particular, as far as the agenda, we'll talk about what the metaverse is. We'll contrast that to the Omniverse. We'll talk about the concept of architectural imagination and what it means for digital twins. We'll talk about construction waste, reduction in emissions, looking at the living building challenge, and then also what does the future of living look like. And so we'll kind of touch base with that. So the metaverse is essentially a virtual world, and the the biggest difference between the metaverse and other technologies such as BIM technology that essentially may do different modeling for construction and architecture. The metaverse is open and connected to the internet in a different type of way. And so Web 2.0 being the internet as it exists, 2.0 meaning 2 dimensions, Web 3.0 is 3-dimensional. So 3 dimensions, 3D virtual reality. And so it allows for all types of different immersive experiences where individuals can collaborate all over the world. It allows for prototyping, testing, and rapidly developing many different concepts. There are definitely efficiencies that can be had as far as workflows, being able to share information in a new type of way, in a more immersive way. And construction and architecture, of course, when you're building these worlds, is truly at the heart of that. And so we're excited about the different opportunities that the metaverse is bringing for individuals to be able to create in the architectural space, and to do so in a way that is highly inexpensive and extremely efficient. So what is the Omniverse? A lot of people have heard about the metaverse, but haven't necessarily heard about the Omniverse. Well, the Omniverse is NVIDIA's version of the metaverse. If you haven't heard who NVIDIA is, they're essentially the largest manufacturer of graphics processing units, or GPUs, which are used for things such as gaming. Right? If you have a nephew or a child that plays video games, it's likely that they're running their video games on NVIDIA's GPUs. GPUs are also used for things such as artificial intelligence. They're used as the brains for self-driving cars, for drones, for a number of different mission critical computing applications. And so what they're doing with that now is they're utilizing these GPUs in order to run the metaverse, which is built on the same technology as AAA games. The Omniverse, likewise, is built on NVIDIA GPUs. So NVIDIA is running the metaverse from a hardware standpoint, and they're running the Omniverse from a hardware standpoint as well. The biggest difference between the Omniverse and the metaverse is primarily that the Omniverse is not only catering towards industry, but they're utilizing enhanced graphics. So they're utilizing, for example, not only Unreal Engine, which has built a number of AAA games, but also at the same time, they're utilizing Pixar's technology as well in order to build these virtual experiences. Another difference is that from this technology and other BIM-related technologies is that you can not only create an architectural space, but you can also integrate artificial intelligence to not only have mannequins essentially, or figurines in your architectural environment in order to essentially augment persons, right? And to get that experience for what it would be like to have occupants in your space. Well, you can, with the metaverse and the Omniverse, but more so the Omniverse, you can animate the occupants in this architectural rendering in order to have artificial intelligence inhabit those animations. And there's all types of things that can be done from translation, real-time translation of various languages by these figurines or by these avatars. And there's also the capability to do speech rendering so that the lips of the avatars move and articulate the same words as the speaker. And so there's a heightened level of realism and capability in these digital worlds, particularly the Omniverse. And so as far as architectural imagination, as the domino house in architecture and design really was a huge turning point for the industry to break away from prior legacy paradigms regarding construction, right? Particularly of residences. And so Le Corbusier, he said, a house is a machine for living in, right? Corbusier said a house is a machine for living in. And the 5 points of architectural design that he emphasized through this domino house structure is, one, to lift the building up off of the ground, which at the time wasn't necessarily a revolutionary concept. You've seen this concept be applied through native populations throughout the world, where they're utilizing this pillar concept in order to keep the dwelling or the residence off of the ground, up from animals or other particular dangers, as well as to keep the dwelling from becoming rank in the terms of all types of different types of plants or mold, for example, that can form along the base of the structure. And so it essentially lifts up that structure. Also, what it does is it allows the underside of the actual structure to be utilized for more things. If you have a basement, for example, United States, a lot of homes have basements, and it's usually a place that's not, even if it's a completely finished basement, it's usually not a place that you want to necessarily be. It's a place where mold easily forms. And then also it's a wasted space to a certain extent. By raising the home on pillars, you're able to utilize the space underneath the home for recreation. You can have grass or vegetation grow there, etc. Also, the pillars allow for free form of interior designs through these particular columns. And so you can create different types of settings. You can construct different formations. You have more free flow of thought and form through this methodology. Also, this allows for free form with the facades, liberating the load-bearing function. At this point in time now, you can have more decorative facades, or you can have facades that have utility, but at the same time don't necessarily have to have the same utility as bearing load. Horizontal windows provide even daylight distribution across the rooms. And then rooftop gardens on flat roofs protect the concrete underneath, and then also create an additional space. And so this really opens up not only the architectural imagination, but when you think about the house is a machine for living, the house is a machine for living. And so coming from the automation side, where we think about pure machines, and then coming to the side where we're looking at the home as a machine and how different processes within the home can be automated, and how automation can truly, automation in addition to artificial intelligence, can truly bring different and new applications where you can automate different aspects of the home. And we'll talk about that when we talk about the future of living. So when we talk about construction waste, the fact that you can use, there are open source metaverse environments. For example, Mozilla Firefox has one. And in these open source environments, you can build and you can test out and try these new concepts before you actually spend money implementing this particular construction plan. Not only can you test out and prototype construction and architectural projects, but also through the metaverse, you can actually switch the settings, right, of the place that you're in. So suppose that you want to be in Brazil. Well, technically, you can actually acquire a 360-degree model of Rio de Janeiro, for example, and you can place your architecture in that city in order to determine what your skyscraper, for example, may look like in this new and different place. In addition to that, you can actually gain some type of social emotional idea regarding how occupants of your structure are going to interact with the spaces within your structure. And so you can see, for example, through avatars in the metaverse that are visiting different aspects of the structure, you can kind of gain an idea about what areas of the building people favor, what people find attractive, and that can't necessarily be done as well if you don't have this three-dimensional social experience where people are able to come to a space and they're able to talk about different aspects of that space as if they were actually there in that space, right? And they were having a cocktail with you and an hors d'oeuvre. And so this just adds a different dynamic to the whole construction process, because it is more immersive, because you can bring people within that space prior to actually creating that space. It prevents a huge amount of waste. An example I'll give is a hotel that's being built in the metaverse. And so they're building this hotel. This hotel also is incorporating its own cryptocurrency in order to fuel its ecosystem. And they're building this space in the metaverse with the goal of later building out the physical hotel in the real world once the metaverse project has been deemed to be successful. And so when you think about how you can save huge amounts of waste to not only determine if an architectural concept has viability, but also if it has social viability. Do people actually want to utilize that space, or is it going to become some type of legacy aspect of the city, right? Or the urban dwelling? And so there's huge cost savings. As far as reductions in emissions, of course, savings from waste, pre-planning. Also, the other interesting aspect is that in the Omniverse, and primarily the Omniverse is unique because it also has physics within that environment. And so you can see how materials would behave in the real world, right? Would high winds, for example, how would they rock the steel structure that you may have created, or your tower? And so you can look at these different dynamics with the physics engine, and you can really get a great idea for how your structure would behave in the real world. With traditional architecture, you model it, build, and then you try to mitigate any waste, of course, throughout the process in different regards, but it's primarily towards the end that you're trying to mitigate the waste, as opposed to really being able to take your time and to truly gather as much information as possible, not only from your colleagues, but really from the public and individuals that may actually utilize your space through that social integration aspect of the metaverse. The Living Building Challenge is interesting. It's one that we've been involved with since about 2015, where we did a feasibility study for a $50 million project. And the Living Building Challenge is the highest green certification in the world. They truly aim to reuse every aspect of the construction process. So you get more points, for example, if you are doing a reconstruction process and you're taking the old materials and you're reusing those materials in the new design of the building, making sure that you aren't subplanting or essentially displacing, right? Too many trees, for example, or disturbing the natural habitat. And so it really is a very high and stringent standard to achieve. And one of the greatest aspects of achieving the living building standard is by ensuring that you have for example, access to all of the different products, right? And making sure that you have blockchain access to those materials and that supply chain so that you can keep track of essentially where these materials are in the world, because it can be difficult to try to find and source all of these sustainable materials on your own to make sure that you meet the high standard of decarbonization. So when we talk about the future of living, is very interesting. We're really talking about the digital and the physical spaces truly merging, and for an individual going in and out of the metaverse at will. I was able to see this to a certain extent when we presented for the first time while inside the metaverse and simultaneously in the real world, right? We weren't delivering this talk remotely. We were in person. And so being in the metaverse and the physical space at the same time, being able to affect both of this digital reality and reality itself at the same time has, unique context. And in addition to that, artificial intelligence and blockchain technology will immensely affect future cities, right, in rural areas. Artificial intelligence itself is going to change the smart home and the smart city to the extent that AI will allow a building to morph based on the occupants, based on their emotional state, right? You walk into a room and the occupant isn't in a great mood. And so, music turns on, the shades go up. Maybe the color scheme of the room changes and the furniture changes and moves and the walls shift, etc. So truly, this is something. For example, it could have been seen in iRobot, right? And in that particular movie, you could see that the smart home really was morphing and shifting in different ways. And that capability truly is here with automation. When we talk about blockchain technology and we talk about the capabilities of information sharing on this distributed ledger and being able to take all of that data and process it in order to enhance the experiences of citygoers and individuals within not only cities, but also rural areas. How do we take all of this information, not only from the buildings itself, information from the occupants of those buildings, information from the residents of the community surrounding that building, and then you really take all that information and you can create truly unique experiences. And so it's our hope that this technology will allow for the reduction in the carbon footprint of many agencies and organizations, and that it truly will allow creativity to flourish and to reach segments of society that is never reached before, in order to truly add more cognitive power to the conversation, in order to essentially get the human race to its carbon emission goals by 2050. Thank you guys for your time, and I look forward to answering any questions if there are any.
Thanks, Ian. And there is one quick question before we go into discussion mode. When you mentioned the hotel that is using the metaverse, is that the Bryce project or a different project?
I do believe it may be a different project.
Okay. So one of the things I'm hearing as I listen to you and Fred, number one, of course, data. What we're hearing is in terms of the transformation of data. So typically, like Fred has been working on the quantity surveying side, and you have your cost, you have your materials, you have your different pain points that you need to drive a construction project. What I'm hearing from you, Ian, is that we now have soft data. So Cecilia can wants to build the domino house and wants to know if it'll fit in Westland's neighborhood. And Fred can do all the costing, and somebody can set up a digital model with a replica of everything that's surrounding the site where I want to build. And I can then go physically, my avatar can go into that space and start reacting to that space. So that then Fred, if I then say, I hate this wall here, Fred can move his team and say, Cecilia doesn't like the wall here. What's the cost of changing the design? Is that what I'm hearing?
Exactly. Instead of after you've built the residence, then you try to take residents through and then say, do you like this? And then they have to rip it out and all the other stuff, right? So you can really build in real time, and you can build in a way that is cooperative and collaborative with the client, right? Like, it's a lot easier for you to actually build together. And then the other aspect is that with the Omniverse, you actually can integrate BIM data with that. So you can integrate some of the traditional data points from your more traditional architectural software into the Omniverse. And so it's not exclusive, like you have to just have BIM or the Omniverse. You can integrate all of these data points in order to truly create new experiences.
And Fred, on those data points, you had started talking to us about sixth dimension being sustainability. Can you tell us a little bit, react to Ian in terms of, okay, this domino house and whether or not I like the aesthetics, what do you do with the 6D data?
So basically, just to recap what I talked about, the approach that we generally apply in managing this data is that we have, it will start from the 3D, which is now the building model, which is where Ian and his team of designers come in. Of course, now all that data will be consolidated in a way that we can have the fourth dimension, which is the time factor, where we will be able to look at how long this process is going to take, from when we start construction to when we shall finish construction. And then, of course, the fifth dimension is the cost factor, which is what we have just discussed. And then, of course, now when we talk about sustainability, we want to look at the impact that this specific project will have, because we have already modeled all the specific angles and factors that will come into the construction of this. We now look at, for the period of time that this project is going to be constructed, which processes are going to have, any significant impact. We will look at, the choice of materials that will go into construction, because we have now broken down this whole building into the basic resource requirement. So then we have a closer a level of control when it comes to such aspects. And then, of course, we have modeled it, and we see how, in terms of setbacks, in terms of interaction with natural bodies such as rivers and just the whole ecology of the site. So it takes care of that and be able to bring you a report in terms of all the data that's been collected. And then now, we're able to impact, or rather assess the impact of the project. So that's really the sixth dimension.
Thanks, Fred. And we have a theme coming in from the chat. Roy is pointing out facilities management has to be part of the deliverables in terms of a major part. And we had CK before talking about facilities management as well. So let's put that in context for people. Both of you are saying we collect the data, we model. What I'm hearing in that is you have, let's say, your IoT sensors collecting your emissions data. And as I'm using my house on a daily basis, it's tracking, is Cecilia generating more than she should out of her house in greenhouse gas emissions? And how does that affect, let's say, the plants around her? You could scan those with a LiDAR, or how does that affect in terms of if she's putting what she shouldn't be doing in terms of dumping household cleaners into freshwater systems? How is that affecting the pollutant load of the water? Because you can also measure that with IoT sensors in the house. How do we make, now that we know what we can do, how do we make that something that changes behavior? And I'll let you start, Ian.
So that's a great question, and I think that's really where the beauty of the Omniverse and the metaverse lie, is that you can experiment regarding the utility and the use case of a particular architectural space before you actually build it in the real world. So you can have people interact with that particular space and then determine, really what is the utility? Am I achieving or accomplishing what I need to accomplish? And that goes right to Roy, I believe was his name, his comment concerning maintenance, right? Well, what if you have a building that is fully functional, and because you integrate blockchain technology and you integrate cryptocurrencies in order to essentially fuel this ecosystem, you have a profitable project that never made it out of the digital world, right? You created it in the digital and it never even made it out. But now that, for example, maybe it's profitable now, and you see that it's a space that people want to be in, then it's something that you actually create in the real world, right? And then you maintain it in the real world. But there's also a factor of having to maintain these digital spaces. And so now that you see, for example, there's facilities management, there's going to be facilities management in the metaverse, in the Omniverse. You're going to have people that are going to have to go into these spaces and update these spaces. For example, there's going to have to be cybersecurity that you're going to have to worry about in a unique way that may be different than the cybersecurity that you need in the physical world, right? You may have a physical space that's built out for servers, for example, and you may have a security guard. Well, what does that security guard look like? Do you have an avatar that's kicking people out of the digital club, etc.? And so there are some dynamics that are not necessarily new, but they're going to have to be replicated across physical and digital spaces that we aren't necessarily thinking about now. And there's these dual roles that some of these players are going to have to play, even though they may not be thinking about it, currently.
So in that context that Ian has just given Fred, let's think about data and data storage. You presented a whole suite. So RIBCCS is not just one software, it's a whole integrated suite of software in terms of collecting the data, different points. If you could speak to, Ian is just saying this hypothetical metaverse where we're now doing maintenance in the metaverse, looking at the cost control issues, and more importantly, a question from Juan is, where does that data get stored? Because we're all worried about, where's my data? Who's my data? Who owns it? Is it on an Amazon server? Is it on the company server? Is it in some blockchain Ian sets up? How does this work?
I can comment on that but you go ahead.
Oh, sure thing. So yeah, just before Ian reacts to that, just to mention about facility management and all that. In terms of cost planning, we always have what you call the project lifecycle costing, yeah, which takes care of all the processes now, which includes facility management in the life of that building, which can give you projections in terms of what to expect. Now, because we're working backwards, that we've seen that we have come up with these costs on the very basic level, which is the resource level, then that can now be extrapolated into carry on that same kind of sustainability, where we can also be able to have a handle on the cost, because it gives us an idea of where we're going to end up at the end. And also now, in terms of data, there's other solutions that are available, which is of course the cloud solutions. We definitely offer that kind of service, of course, but to clients who would want to have their data domiciled on a cloud, where now various people who have the rights can be able to access that information. But generally, I think there's need to, if I understood the question correctly, there's need to do more in terms of collecting all this data in a way that can be modeled into something that can be replicated. Say that, okay, this is what we have learned from X number of projects, in terms of sustainability, and then these are the indices that we look at. So probably more needs to be done in terms of consolidating this data. But in terms of from our side, data security is something that we take very seriously, and we can definitely make use of the cloud facilities and solutions.
And Ian, you wanted to comment?
Yes. So for the data in the metaverse, that's a particular concept. Regarding that, of course, you do have the capability to store data in the cloud, but also you're seeing a lot of people, for example, in the blockchain in the Web 3.0 sphere, and a lot of these players are the same, right? Those individuals in the Web3 space and those individuals in the metaverse space. And it's actually the culture in Web 3.0 to be decentralized and to run your own servers on your own computers and your own systems. And so I think you're going to see more and more people that are going to be running some of this technology locally on their devices. I also do believe, for example, there's a concept called federated learning in the field of artificial intelligence, where instead of taking all of the data off of a person's mobile device, you're able to train the artificial intelligence on the data on that person's mobile device. And then that way you don't have to move these huge amounts of data around the internet. And so with that being said, technically also data could be stored on your mobile device. An organization could get the information that they need without necessarily having to store that information anywhere, right? Outside of where it is natively stored on your mobile device. And so we really are going towards some creative and innovative solutions, especially those type of solutions will enhance cybersecurity, because really you're just looking at a person's data, making a decision based off of what you see in their data, but you're never moving their data, and you're never storing their data. And so there are some solutions for that, but those solutions are essentially being worked on and they're not widely available yet.
In speaking of solutions, so hypothetical scenario, everybody, us, this team, the Share Your Green Design team, people who are watching are so excited. We want to do a pilot project and we want to figure out how to come together in an online space and design a sort of, let's say, cadre of like a whole city block here in Nairobi. Is the software that you're mentioning, people are now used to freemium to premium, so you get started and then you then switch to premium. Are there options for that? Can you get started with that? Or do you need to assemble a team and already know, we're gonna be purchasing the license and what kind of computer equipment do you need to get and how much training background? Is it intuitive or do you need to really have been already, like Fred's saying, working with quantity surveyors and engineers who already know how to use BIM in terms of just getting in and getting on the ground started?
I think that there's two aspects to it. I think that when you start talking about integrating BIM and you start talking about some of the data points that Fred's talking about, I do believe that you're going to have to eventually bring somebody in that has a strong, project management, construction, architectural background, or engineering. However, on the actual creation of the spaces, there are going to be all kinds of new opportunities. And I think that the actual development and building of the metaverse, which in many aspects, they're actually trying to, like NVIDIA, for example, is working on a exact replica of the entire Earth, right? And technically, in all of the metaverse worlds, you can have infinite worlds with infinite, construction going on. And so, for example, when I went to Dubai for the first time around 2010, 2011, when all those buildings were just going up, right? And they're taking all these populations from India and bringing them in to the United Arab Emirates in order to facilitate this construction. There's going to be similar economic opportunities in the metaverse for large groups of populations that know how to build in the metaverse to actually build in the metaverse. And we've worked with populations and have shown them how to build this technology that were completely unskilled and didn't have a technical background. And so you can teach a person to build in the metaverse. Now, whether you also teach them architectural principles in the midst of that, that's something that may be beneficial. But essentially, they're using gaming technology, and they've basically been preparing the young people to be able to take on these type of roles since gaming, existed in its more modern form. And so because of that, the gaming technology really is a bridge to the metaverse. And so essentially, if the kids or the young people, because you have a lot of people from my generation, for example, I'm a millennial that also grew up playing games, then they really already have a skill set that can easily be applied and transferred to the metaverse. And so, yes, there's definitely going to be huge opportunities for workforces to actually work and to help build the metaverse out for organizations and for nation states around the world.
We have a question about NFTs, but before we get to that, then Fred, in this same hypothetical scenario, I'm trying to then make this game of building the property as realistic as possible. So I set a construction goal of reduction of 40% rework, and I want a reduction on 30% on materials used. Am I able to take your RIBCCS tools and do that, or also take us through the process like Ian did?
Well, basically, we'll definitely need to start from the needs analysis, which you have ably described as, you want to control rework based on the processes that are on site. So needs analysis will basically look like We then set up a consultative session where we look at your current processes, your current softwares, and then we can now analyze and see what we can definitely optimize for you, and then give you a fit for purpose solution. You see, like as I was explaining, there's many aspects to the complete solution of enterprise efficiency that we offer. But then you may find that for some other clients, only one would do well in the interim, or all the solutions would work well in the interim. So we definitely need to start from a needs analysis, and then now moving forward, then we can have discussions, maybe with your technical team, just to see what challenges that they face, on site. And then now, of course, we will now come in and provide the solution based on your specific need. So basically that's where it would start. And we have a team of experts. Even if it will not be myself, it will be another engineer or another quantity surveyor or a project manager who understands this construction world as it is.
I wanted to circle back and touch on a couple of points that I felt was important, if you don't mind, Cecilia. I wanted to touch base on the expenses and just the accessibility of the technology. And so if you're going to work on the Omniverse, then you're going to need NVIDIA's hardware. And these are GPUs. And GPUs actually, I mean, you can get, it can be cost limiting in certain parts of the world. It costs maybe, I guess for a lower version GPU, mid grade, probably $300 to $500. However, you can basically, if you can afford a gaming laptop, which you can probably get a nice gaming, like a newer, higher end gaming laptop for maybe like $1,000, you can utilize that. However, there is technology like the suite of Jetsons, which are basically you're taking away the screen from the computer and the keyboard from the computer, and you're just utilizing the GPU. And then you're hooking up your own keyboard and your own monitor to that GPU. So that's the Jetson family. They're basically taking the GPUs out of the machine and allowing hobbyists and industry to work with the GPU any way that they want to. And so there are Jetson Nanos, for example, that may be like $100, right? Like maybe 150 max. And so you could create, like we've done this before, we've created labs where we just have Jetson Nanos set up and individuals come to work on those instead of any traditional computer. And so you can do it for a low cost and have these individuals work on these environments. Also with, but that's free for individuals to build on, but there's a paywall for enterprises to actually access those services, right? And so if you build, you can build on a marketplace, and then you can sell those products and services in the Omniverse market, right? So you can capitalize on some of that. On the other side with the metaverse, for example, you have Mozilla Firefox that has a project that's completely open source. And so you don't have to pay anything at all to build in the metaverse. In addition to that, individuals are able to access the metaverse through mobile devices. And so, for example, in our actual metaverse facility, individuals can access our metaverse using a mobile phone. So they don't actually need to purchase $200 or $300 VR goggles in order to access that space. And so I think that's what's so huge for Africa with the metaverse, is that through smartphones, Africa can access the metaverse cheaply, quickly, and really just introduce all the young people to the technology that are going to help really build the next Web 3.0, but also the next real world, right? As far as green sustainability is concerned.
So we have a question on NFT, and then I'll go back to Fred. So the question on NFT is, you have two different types of asset. You have a digital asset and you have a physical asset. Do you own both? If you build the NFT, if you build in the metaverse and you have NFTs around that, does that automatically mean you own the physical asset and vice versa?
And so it depends, right? It depends. If that's the way that the smart contract, which is essentially underlying NFTs and other cryptocurrencies, if the smart contract says that individuals that own this NFT also own the physical space, then yes, that's completely possible. The other possibility is that you have things like a DAO, which is a decentralized autonomous organization, where you're basically bringing a bunch of people together that have a little bit of money in order to buy or purchase big things, right? And so here in the United States, for example, you have a DAO where people are trying to come together to buy a national football team, right? Which normally only billionaires can do that. But through the utilization of a DAO, you can crowdsource all of this funding and all of these ideas in order to really build projects that you wouldn't be able to before. So with this concept, suppose that a community wants a new park or they want some type of hydroelectric facility, they can actually crowdfund themselves and put their money together through cryptocurrencies or NFTs, etc. And they could also build that project not only in the digital world, but then build it in the physical world and utilize their own cryptocurrencies in order to facilitate that and facilitate future transactions throughout that particular ecosystem. So there's very interesting things that can be done that have yet to be done. And so it's an exciting time to be alive, particularly in this space.
So one of the things I'm hearing then, when you're saying the DAO, we have a concept in Kenya called Chama, which is a group of people get together, and it's the same thing. You put your money in a pool for a particular process. What I'm hearing is, though, in that Chama, we not just need people who are willing to put in time and money. From what I'm hearing from Fred, we need people with the expertise. So we need the engineers, we need the architects, we need the project managers who know the process. So that if we say we're going to build a living building challenge on Diani Beach, we also need to know, has the team the expertise that we're working with? Have they worked in sort of the coastal environment before? Or are they only experienced in sort of working in Nairobi, and how would that change? Fred, if you could speak to those kind of decisions in terms of as you're using, like in your experience, seeing different clients using the software, where do they get challenges? Where do they get stuck? How, in terms of translating your tacit knowledge and your operational knowledge into a digital storage and analytical system, where is it that people get stuck?
The biggest challenge in my experience and opinion is letting go of previous ideas. People have I've had experiences where I've presented a solution to someone, and they're like, I've been working on my templates for the past 20 years, and they weren't very receptive to this sort of change. The challenge herein lies not only in having the right expertise, but also the right attitude in terms of taking up solutions, because people have a sense of mistrust, that we may probably lose our data, or we may probably have a data breach at some point, or this thing will just crash one day, and I'll not be able to have any reference point of my projects. But you see, what they're forgetting really is that despite being a huge industry. Construction has really lagged behind in terms of digitization and taking up technology. And I was having a discussion with a few guys, and we were talking about how revolutions are utterly disrespectful. They will not ask you if are you ready, to take part in this. So this in this digital revolution, the world will definitely move on and move forward, and with such amazing things that like Ian is talking about in the metaverse and all these concepts, we cannot afford to fall behind. And also that's why, even as part of our own processes, we normally have consistent training and mentorship for guys who want to come on board. We normally do a lot of hand holding, just to make sure that their transition from the previous systems, which were, are now becoming fast a cake, to becoming now, a fully digitized company. So we normally do a lot of hand holding and just guiding in a way that would help them in this transition.
Thanks for that. And then we'll wrap up the Q&A with a future thinking question for each of you. So Ian, you mentioned we can get started with $100, $150 on your mobile phone. Like Fred is saying, Africa cannot decide to opt out. This revolution is here. The river is flowing. We need to jump in and learn how to swim. So Ian, what is your sort of future vision for how this plays out? And then Fred, it'll be the same. After hearing Ian, what is your future vision for how this plays out?
So great question. So my future vision is all over Africa. You have individuals, young and old, that are interacting daily with the metaverse, whether for work, school, or play, and they're doing so primarily through their smartphones. In addition to that, I see all kinds of economies of scale, because I'm just going to be frank. The African mind, the creativity that is there, we don't have to really speak on. And that creativity has not really touched the metaverse, and it hasn't really touched Web 3.0 yet. And so when it does, there are going to be all kinds of things that are going to take place. For example, when we talk about fashion, when we talk about music, etc., those things haven't really hit the metaverse yet. And so there's all kinds of opportunities to allow individuals that have been cut off from economic resources to be able to access those resources. And so I see a world that is more connected, that has more freedom, because through coding, through digital freedom, right? There's a different type of freedom. And a lot of these applications are going to be so easy to use that they're going to be zero code. So you're going to have a lot of people that normally had to code in order to obtain these type of digital freedoms. And that's not going to be the case anymore. And so I'm really excited about particularly what the young and old are going to do with this technology once they actually are aware of it, and they have it in their hands.
Yeah, thanks. Just to ride on that point as well, it really is exciting, and you can almost feel it in the air. That it's a tide that's changing. Having worked on both sides of the divide, I'm a millennial as well, as just like Ian said, and we have seen the best of both worlds, where things were terribly analog, and we have been part of this transition into a digitized society, and more so now in construction, because I've also worked in construction where everything was horribly analog, and I can already see that there's so much potential, especially in Africa, given that there's so much growth potential for the next years going into 2030, and we know that even in construction that it's one of the highest ranking in terms of value of investment, and so we need to definitely have a keen look at this and see how all these various sectors will interplay. But also chiefly it would be nice to be able to replicate a lot of these projects and to see how we can take part in reduction of the overall impact in terms of the carbon footprint in our construction processes. I'm very keen on seeing how digitizing our processes, as we have already begun, will have an impact in the coming years, at least to make a better home for ourselves and the generations to come.
And I'll leave this as a parting before we go into the break. What I'm hearing from both of you is actually very exciting. So, given that we can build properties in the virtual space and we can monetize them through this NFT and blockchain process, what I'm hearing is it's possible, like before, if I wanted to start my own hotel or my own sort of fashion boutique studio, even if I had the skills, I had to have that capital asset of building the physical space. So let's say for a hotel, I have this dream of building a hotel. In my case, it might be a research lab, and I know the capital cost in the physical space is about anywhere from 50 million to 100 million US. And investors are telling me, will it generate return? What I'm hearing is with Ian is between for $100 to $150, we can build this thing in the metaverse, in the omniverse, start bringing in people like Fred and his team and saying, first on the construction side, but especially on the facilities management side, which is a cost critical thing for both operating hotels or operating a scientific research lab. You have so many issues in scientific research lab. You have a lot of toxic fumes and all of that, and there's a lot of changeovers. With the hotel, of course, wear and tear, and things happen, fires break out. So we can actually operate all of this in the metaverse and as if it were a physical building, and we could monetize this, we could run this, and we could do it so that by the time we say to an investor, I want 150 million to get that started, we have the numbers to show, yes, it works. Is that what I'm hearing?
Exactly. And one of the things that I like to compare and contrast it to, because people think about the metaverse so differently than they do Web 2.0 or the current version of the internet. But for example, right now we're having a conversation via this video webcast, and it's a two-dimensional experience. We could, in the physical, in the digital world or in the metaverse, we could actually be inside a studio, or we could be inside an office building of one of our organizations, and our avatars could actually be interacting and going back and forth. And so really it's truly enhancing the immersiveness of that experience. When you talk about being able to monetize these different projects, yes, I mean, the interesting part is that you can spend currency in the digital world and then go to the physical building that's created later and spend that same money, right? Like when you come in to pay for your room in this hotel. And so really we're talking about huge amounts of efficiency where you only build something if there's a need or desire for it, and you determine online whether or not people want to engage in that space, which gives you huge leverage when you go to investors saying, we have this hotel that already has, 1 million different clients, and we want to build these hotels in the physical world because we're already making money. And what's going to happen is that you're likely going to have these organizations that build these physicals or these digital spaces, and then they have enough money to where they don't even need to go to investors, because they're able to source all the funds from the people who love the project. And the people who love the project are what the source for the funds in order for that organization to build that project out in the real world based on the needs and desires of the people. And so, you know, the decentralization of it, the fact that it puts power into the hands of your average person is truly, you know, the power that lies behind the technology.
And Fred, in terms of facilities management, the same concept as Ian, what do you see the power of the platform, the integrated platform you offer, in terms of if this was a virtual, if it was an omniverse building?
Basically, because this is something that we have definitely explored at length, I foresee, of course, a better level of control when it comes to facilities management. Of course, now because we're able to replicate various scenarios hypothetically, then we can be able to see the far-reaching implications of some of these actions before they actually happen, and then you know, of course, we can be able to mitigate and control much better. Of course, now it's just giving more power into our hands as the building managers and designers. Thanks.
That's actually a neat idea, because I'm Lean Six Sigma black belt, and one thing that we do is we do trial runs. We separate people into groups and we say, okay, does this intervention work? Yes, no. So it'd be really cool to have, like, you know, everybody, typically in management, you have everybody competing or arguing my way is better. But then what I'm hearing from you, Fred, is we could separate out everybody's theory on how to improve the operational efficiency. And we could do this runtime and do these trial runs in the metaverse using the real software that we would use, the RIBCCS suite. And we could use that. And then once the data plays out, then that's the one we adopt, rather than doing that time, taking that time out of the physical space. All right, and with that, thank you, Sharon. And Sharon is saying she really enjoyed this excellent presentation. We will take a break, and then we'll have even more after the break with Cedrix, who will actually show us case studies and buildings from the actual that have been done within Africa. So thank you, everybody, and thank you, Ian and Fred. This has been great.
Thank you,
All
Cecilia.
right. Thank you, Cecilia. Thanks for it.
Welcome back, everybody, and hope you got some stretching during the break. Give yourself some calisthenics. Now we're going into looking at the buildings themselves. We've been talking about the building technology and the virtual environment, and we have with us Cedrix, or Cedrix, I pronounce things with a Spanish accent, Tsambang, who is CEO and founder of Course Architecture and also the country representative for BIM Africa, Building Information Modeling Africa. Hi. And he will present case studies and also take us through actual, like the design and the physical spaces that we've been talking about. So over to you. Oh, we can't hear you. Oh. Still. And it could be on our end too, because we had a challenge.
Hello?
Now we
Is
hear
okay
you.
now?
Yes.
Yes, my mic was muted, so it's all good. So I'm privileged to be with you. One was not easy. So you said your accent was from Spanish. Mine is a little bit French. So, but we have it all good. I'm sharing my screen. Yeah. Okay. So as you can see, my title is From Scratch. I've been hearing the great guys speak before. They've been talking about, let's say, deep things. But let us start from scratch. How can we really apply, or at which level can we start to apply digital twins, digital modeling, BIM in Africa? In fact, I'll be trying to explain how we are trying to do it. So the main idea is to give a definition, general definition of digital design, digital twins, how we use digital twins in a small particular project, and then how we are approaching it from scratch with Coros architecture. So from scratch, first of all, what is a digital twin? There are many definitions. Obviously, some have been given in the beginning, but a digital twin is all about a set of virtual information constructs that mimic the structure of an individual unique physical asset. It is dynamically updated with data from its physical twin through its life cycle and informed decision that realize value. So the idea is that we have to realize value, and to realize value, you must make sure that you are not committing error at the end. And if you are committing error, we use digital tools later on to be sure that we are getting the right data, the right informations to move on. So during the process, we can have many steps. Some people don't consider idea as a step with digital tools, but when I will be explaining how we use it, we might understand when we will put idea there. So from idea, we move to concept, from concept to design, to manufacturing, operation, post-life, recycle or reuse, or even retreat. Uh, I will talk of manufacturing. In Africa, we don't have much. In sub-Saharan Africa, we don't have too much of manufacturing, not yet, but it's on the rise. And we depend on technologies from abroad, from other countries that are developed in particular and for particular context. They are not always the one that will work well in our context. It's the same thing with concepts. When you don't develop concepts from rooted ideas, you might start with concepts that are not contextualized and that are not solving the right problem. Like Einstein once said, if you have 1 hour, I think, to save the world, who will spend 45 minutes defining the problem. So in that case, we use digital twin for non-tangible, as define it as a non-tangible virtual replica of physical data. Why non-tangible? We'll see it later. So there are many tools that are used, but the simple ones or the easiest one to catch on to understand first are the use of sensors to collect real-time informations. We can have it in cities. Actually, we can start from scratch with those type of tools. We can develop it. We can buy it. We can easily access the operators, may it be in Africa or abroad, to have it placed on in our cities to manage and to start collecting data as from now, to be sure that we better construct the cities we want. You have computational fluid dynamics. We've been talking of net zero architecture. We're talking of, in general, sustainable architecture. But how can we be sure that what we are talking of is not just, how did I say in English, something we have in mind, but that we can easily actually verify it and be sure that it's improving? More so that if you have the appropriate data, we can start designing we are in 2022 as if we were in 2015, meaning that in 50, meaning that we know that what are the worst conditions, and we are designing with those conditions, and we can simulate it. We have smart tools that are also affordable and that we can start using now, even in remote places. Okay, you have data science, data analysis. So I'll be tackling all the issues as an architect, not the IT expert or whatever. But in a digital world, collaboration, cooperation, and multidisciplinary approaches are the best way to have it. We have artificial intelligence, of course, and the Internet of Things. So that are the simple stuff that everybody can access at various price, obviously, at various scales, obviously, but you can start by them to understand how digital tools works and how it can help us. And as designers, it's more easy for us to start here than to enter into complex notions. So as an example of how we've used the tools, we'll be brief. We had the air quality week in Yaoundé, is the capital of Cameroon, central of Africa, the country of the indomitable lions. We are known for football, but let's start to be known for architecture. So it was a typical town planning operation. The idea is to start improving the quality of life in the city. So the council with partners decided to place captors in the cities, in the city, and we were called upon to provide an exhibition to present to people what the captors and how they work. So the idea is simple. We designed some bamboo stuff at the place of other type of materials that are used in the street that can serve as samples for people to understand that we can change the materials, change the ways to have a better air quality. So in that project, Atmotrack, with no publicity, develop a software called Kaeli. We can have access it by phone, even in other countries you can access it, and you will know the quality of air in each district in the city at real time. So that can be assimilated to an Internet of Things, or you have real-time information straight. Here I tested it when I was putting this together at 9 a.m. and they say like it's in French, la qualité de l'air est bonne. The air quality is good. So during the whole day, you will know when the quality of air is good, when it's bad, and we captures on your project, on your house, on your equipment, especially in nursery, in schools. The window can close at specific hours. They can open at specific hour. You can design knowing how is the quality of air. You can survey it for a long period of time. So here is a simple example of how you can manage the quality of air, and we know how much how the quantity of air is spoiled due to lack of public transportation. Everybody is going by his car, and by that you can easily organize sessions to explain to people that you see at this peak the quality of air is bad because there are many cars outside, or because it's the period where industries are working. So if you want a better life, you can do this and do this and do that. So it's easy way to approach the population. And for architects like us, it will serve to design to understand that air is part of the project. Air is a material, so we can manage it and use it to advance. But before advancing, there's sometimes a confusion between BIM and digital twins. Obviously, it's not one of the same thing, but they must go together. But to better understand, we have some digital category here. Idea concept is better developed in BIM because you don't need, not absolutely need digital twins to develop ideal concept. But when it comes to operation and maintenance, or to analyze a project, real-time operational changes in the digital model, simulation of dynamic processes, optimization of functionality, life cycle of the building, parameter and data generation, you are better served by the digital twin. So once you have your BIM model completed and well executed, and you'll be helped by the appropriate quantity surveyor, managers, architect, engineer, whatever, you now have to make sure that you digitalize the process, or you prepare the model to start operating in parallel with the construction or with the project, and you can do that from the beginning. So talking of it's a bit disturbing. So talking of BIM Africa, of BIM, we have BIM Africa, and the role of BIM Africa is to advocate BIM, obviously. So it's almost in all the represented in all the countries in Africa. Let me go back. Oh, it's a bit disturbing. The mission is to create collaborative and united voice toward digital transformation of Africa built environment. So it's not the name can be BIM, but it's not only about BIM. Yes, facilitate academic and market research toward effective BIM adoption and implementation, engage volunteers and members across Africa country for effective local representation. So if anybody is interested to represent BIM Africa in his country, it will be helpful, and it will help us too to collaborate with various contexts and conditions, especially because architecture will settle in Cameroon because of the 4 different geographical areas and the 2 languages, French and English. So you are sure that you can cover a lot of places in Africa of type of climate being touched just by running in this one country. So the goal is to educate more than 500,000 African construction entities on BIM to facilitate policies and so on and so forth. So the team is, as you see. The partners, obviously, we gladly have Share Your Green Design as partner, and I'm sure that the board will be happy to discuss about that potential partnership. We've been very impressed by what you are doing. So that's why, even though it was just 2 days, I just said, okay, I'll do my best to share. So now the aim of everything, as far as we are concerned, is to go green, is to build sustainability, and sustainability is the core. So how can we help ourselves of digital tools to better understand our environment, to better understand our materials, to better understand constructive construction techniques, materials, and so on, without being depending on a yet to be dynamic manufacturing industry, especially because we have the opportunity in Africa and in many countries to move from scratch, meaning to move from local typology level to directly to green and sustainable project without passing through the modern stuffs or through the boxes developed by industrialization. So as you can see in the image, I will explain later. Uh, when you analyze your project, you do simulation, you analyze the various materials, you analyze the spatial typologies, you analyze the sun, you analyze, I mean, the environment in general, lighting, natural lighting, artificial lighting, acoustics, all the stuff that needs to be analyzed to upgrade the project. Like when you go to Energy Plus to know the type of climate in which you are, how it operates, how the seasons are, everything, and then you come back to your local expression. You understand that there are some materials you don't need, there are some technique that you don't need that you can replace in a room, in a hotel, the floor by grass. Can be a little bit weird, but you have a natural element that whose behavior is different from another one that you just use to have another sense of perception. You have, for instance, images is representing, hopefully will be built, is representing a theater. How do you say theater? Theater, yes. We can really replace, due to the sun, due to natural material, due to natural lighting analysis, many of the elements in the project. Oh, oops. Here is the project in general. It's supposed to be in the capital city. Having analyzed the quality of air, having analyzed the natural topologies and everything, we are sure that it can work here. So to enter in understanding how we come to those type of ideas, and not just by going straight to biophilic design, but analyzing from our context. It's true, we will see many things in French, but I'll translate and explain in English. First of all, illustration don't have a language barrier. So when you see those different types of phones, they can be stated or considered as beautiful or ugly or whatever. But the main thing is how it works. So we've been struggling to design net zero architectures, productive architecture, and so on and so forth. But we have examples, and in Africa, all around the world, we have examples, but in Africa, they're still very present, and some can still be visited and analyzed in the proper way, not just for to save the heritage and the legacy, or not just to stand as cultural element, but also to understand complete reversibility, complete integration in social context, the use, the way people master space and analyze space. So since the difference between the two types of technology, the two types of phone here, is the integrated, uh, is the functioning, we do the same thing with the local and traditional housing. We analyze what they call the screens. Screens is the various part, the wall and everything. Project of Francis Ray can be analyzed with in regard of the tools are presented in the beginning, And you can then analyze every and all the type of material in each location here, and then start to redesign them, to re-understand them, to re-engineer them, and then to properly fix it, to understand how it works. Because we know that those projects are sustainable. They are, as far as they are environmentally friendly, they are socially inclusive, and they are economically the worth the time spent on analyzing them. So we will be doing models, analyzing the models, and not just analyzing it with form and shape, but by putting sensors, captors there to understand humidity level and so on and so. Is it good for health? Is it bad for health? We work together and alongside with medical doctors to understand the environment. We know that those materials are totally reversible. So once they are back, once the project is destroyed, the house is destroyed, the compound is destroyed, it come back to becoming a normal natural element. So how can we reuse it? How can you process it back without destroying that totally reversible particularities and so on and so forth? We analyze the milieu, and we don't just analyze it like I say from by shape or by discussing. We use sensors to be sure how they move in the space, how they go up and down. And here, for instance, is a main palace in the country, a traditional palace, Fumban. We are yet to put captors there, but we want to see how many people are entering, how are they moving there during ceremony period and everything, to have a clue of how mobility, how space organization is being done, not just by what we see or by what is explained, but by analyzing it deeper and deeper. So we go from shape level to material level, and then try to do simulations. Like I said, you don't have the time to discuss with all the partners, and also the agreement with you to present all the different and tools that are used or enterprises with publicity and everything going on. But I can explain it. We try to scale it back. How can you have a village in a high rise? Question like that have been asked. How can you have farming in sky rise and so on and so forth to have productive architecture? But to be sure that it's a weak question, but how can a high rise of about 100 floors be totally reversible, but at the same time be affordable, economically have make sense and can stand for hundreds, 200s of years, and the day that the population has is increased at the point that you have to without destroying the environment and stuff like that. So we'll try to do simulation, and with dynamic analysis, you can see how the wind will flow in, up and down, and so on and so forth. So what we know, like I've been emphasizing on it, is those local models are in front of us. They are, for many parts of rural Africa, the reality where people are living. They are enjoying their lives. On is we are the ones to come and disturb them with globalization, with global warming, and all those strategies. But we must learn from it. We must learn from them, from those. And at the meantime, we must learn from high bodage. Obviously, this you don't need to go and be doing deep learning or analysis, because you have articles you can read directly to understand it. So I will come down with hybrid models, maybe the same shape, but we can put it in various areas using different materials that have been analyzed. And more so in the La Fondation Jacques Rouget, where we are tackling more constrained, more complicated situations. The idea is simply to use scenography, digital twins, digital modeling to understand in the worst case scenario how we can live on Earth, abroad, elsewhere, and on various and different milieu. Say everybody smile the same language, so we have to find a way to use artificial intelligence from scratch to analyze what is already working, at least environmentally, because even if economically or for health purpose or socially. Those type of model are not more working nowadays because of the increase of the population, the scarcity of resources, global warming, climate, the way they use the land to farm and everything. They are totally and naturally friendly. So from that, we can start to say, okay, um, biomimetism, how can we innovate? How can we tackle everything? Innovation, durability, reconnection, everything. So using digital tools can help us understand the three level. Here is written in French. Uh, Trois niveaux d'inspiration. It means three level of inspiration. The shape, how is the shape? Why is the shape? For instance, in the project I was presenting in the beginning, this tower, we use the shape of the Mosgum house in the north of Cameroon that were associated with face mask. But we analyze the shape, we analyze the process, and like I say, it's open to everybody. You can contact any IT company, any web developer to produce you sensors, captors, or you can reproduce the model live. You can reproduce it and then do simulation, computational simulations to better understand. And the main idea and the main thing is to understand is the relation, the ecosystem, and everything. So I will not present chorus. Obviously, question will be there to foretake it. But they are simple with the parts like this in the side with these raw materials, well done, protected, totally reversible. I insist on that. Why is our future like this? We uh, why are we not changing the level of how we analyze it? So with digital technology, we can reframe Franz Fanon, who said each generation should find his mission and fulfill it. So due to that, we can, when you enter in a case study like this one, you have a project in the forest, for instance. Part of Cameroon is in the forest. After you've done your cool architecture analysis and everything, you must understand how the forest was. How does the forest was? So we partner with ethnobotanicians and so on and so forth, and climate change specialists to understand, okay, which is the quantity of what are we destroying exactly? Are we able to replace it? How can we quantify it? And with a digital twin, we can analyze it. And once we have built the project, we can still continue analyzing to master how much we've destroyed the environment or how much we've upgraded, if possible, that environment. So we'll be doing small analysis like this, due maybe to lack of means, to lack of uh, research lab and everything. But with those small sensors, you are able to process small things like this and to move on. And then, no, I will not play it. And then, yeah, you analyze the impact of a wall. You can just, in a campus like this, build two walls, an earth one and a concrete one. And with special captors, you verify during maybe a period of 6 months how those work behave in the special environment, and so on and so forth, to have clean and good notion. So before I wrap everything up, uh, why are we even doing that, and what is the scenario on which we are standing to do that? We know that our environment will be destroyed if we continue to behave as we are behaving. Some are climate, they say they don't believe in the impact, the human impact in the destruction of the environment. That notwithstanding, the environment is going bad and is going worse and worse. So we must do something. So there are many scenarios. The first one is, if we continue the development as we are doing, we'll destroy everything. That's for sure. Yes, that's the scenario we're heading to now. Without changing anything, we destroy everything. But and that scenario we call it no life. There's another scenario where we practice sustainability by trying to save what is existing. One thing is sure, the population will increase, the scarcity will increase. So we have to find a way, not just to, because in this scenario we are calling it no growth. We are not growing, we will not be growing. With change, we just have a standard way, and at the end of the day, we come back to no life. So the main thing is to reconnect from here to the past, where we have not destroyed anything, and that scenario, sorry to go fast, is where we are heading to, and is what we are trying to tackle. And that scenario, we call it no worries, because being able to develop totally reversible and not disruptive project, we'll be able to have a better management of resources, a better management of our planets. So with that said, I'm done. I don't know if I took too much time or less time.
No, you were perfect, Cedrix. This actually is. There's so much to unpack. It could be like 2 weeks of unpacking everything you presented. Let's start with the excitement that under BIM Africa, there is a network because you said Cameroon is known for football. You know, no, you can't have a one-team football league, right? So tell us
Yeah.
a little bit about the opportunities there, and then I'll keep on unpacking.
Can you ask the question? I had a small.
Oh, sorry. Can you tell us a little bit about before, because I want to spend most of the time in what you said about architecture, but for those in the audience who are saying, where can I find more people like Cedrix? Where can I is BIM Africa? Where can people find others who are working towards this?
Oh, yes, in BIM Africa, obviously, you will find, because there's a research part. That's why BIM Africa is having partners. They cannot, they're advocating standing on profile they discover or profile that come close to them. So if you go close to BIM Africa, first of all the partners are doing research in IT or in sustainable architecture, because we have to have an African way, not African in the type, not just to have an African way, because the context is different, the climate is different, the cultures are different. So we want really to use art culture in sustainability, in the sense that we can quantify it. So there are many profiles. Like I was invited by one of the profiles to work in my own country. I did not even know that there was a air quality analysis and so on. But knowing that I was there, they invited me. So also, Chorus Architecture have an initiative called ArchiTalk at the end of each year. So by going to our YouTube channel, Chorus Architecture, you will see various profiles have been speaking there, and who will freely speak in share design, or share your green design, or collaborate, because we are all open. We are just asking ourselves questions and finding ways to try to see how we can go forward. There's also CPDI Africa, a partner of BIM Africa too, where it's all about being Afrocentric. And there you can have, what I love there is that they develop scenography based on African culture. And my gain is that when I see them, I say, okay, if I can collaborate with those who are developing it, because everybody in a specific country understand better the culture. But what I want to do is quantify, analyze, and be sure that, okay, from now we will not more say we don't have a story. We will not more say that we've developed intuitively. Yes, that's the thing.
And that leads into the second question. So on the CSTI side, which we're partnering with Sherry Green side, we're UNESCO Associated Center. And for those who don't know, UNESCO believes that technology and culture cannot be separated. So the cultural heritage, like Cedrix just presented, you can have a Romanesque structure, but then you can have a Cameroonian structure, and that has to be part of the industrialization. You need to develop your industrial and scientific tools from the cultural base in which you are familiar with. So I mean, you have so many fantastic models, not only of the vernacular architecture, you had heritage architecture in there too. And then you're now showing how to translate that into modern architecture for those who say, oh, that's an old building from, old community from 300 years. Nobody needs that in the modern world. You can't use, where do I plug my iPhone? You're bringing that knowledge into the modern space. So Juan is asking, how could we take those lessons and do that more often, do that in more places across Africa?
First of all, we must learn to learn from those vernacular architects, so-called vernacular. I don't like the word vernacular. I call it local architecture. That's why the office part of Chorus is called Local 3.0, meaning local architecture upgraded or add computer when you add computer science. The first thing is to go towards those architecture, if possible, physically there, to analyze it. We have even some partners that have 3D scanner. They scan the building. They can scan a whole building. If you don't have those things, you can just do natural, like we architects we do. You measure everything. You redraw it properly. You have there's a community called Ugreen where you can learn how to go and analyze the specific climates all around the world. So you will be able to do a proper simulation. For instance, I did not have the authorization to share it due to the time, but we did a project in the far north where climate is more, the heat is bigger than in the forest, obviously, because it's close to the desertic regions. So we have to do dynamic simulation to understand how the heat and the element will vary during the day, because it is a primary and a pre-nursery school. We have kids there. We have to be sure that, okay, the size of the material, and so on and so forth. But to do that, we must first of all analyze where they are living and how they are living. And a little bit of humility will not kill us, because one thing is sure, those architecture are totally reversible, meaning they are working environmentally friendly speaking. They have nothing to discuss with the high techs or even what we are developing for Mars and so on. So it's a starting point. Go towards local culture, analyze them. If you don't have the possibility to travel, or maybe if you are not in Africa, you are living abroad, there are events where they discuss about it. Like I said, there's a Shitol each year. People represent from all of many countries. Even Brazil is about rooted architecture wherever we can find it naturally, and people still living it to relate with them. But also CPD Africa, Afrocentric architecture. You can go there. They are providing lectures. I too will soon be a lecturer there, so I hope I'll make my class available soon. They are providing lectures for people to understand specific architecture, and once you have the process, you can move along with.
So we'll get those links from you after, and we'll post them and share them
Oh,
in
no problem.
The other part is then you had, and thank you for the fantastic imagery in your presentation. You had so many stunning buildings and so many stunning backgrounds. And One of the things that we were talking about with the previous two speakers is the power of the metaverse and the omniverse to create a virtual space. So, for just to give the audience a background, like I could take one of those designs, those renderings that Cedrix had, and I could change my virtual background right now, and I would quote unquote be in his space, but in the that's a 2D change. In the omniverse, he would be able to do is create sort of a 3D environment where I'm moving through his space. And I can send him the sensor data from here in Nairobi over my phone, and he can then see how his building design responds to that.
Obviously, yeah.
Yeah. If you could speak about, you were saying collaboration, you could speak about sort of your vision for how these collaborations could take place.
When you talk of metaverse, I think that is a great opportunity, the means to break the barrier of when we were talking about in the beginning. People are not believing in shifting from directly from traditional to modern while skipping all what is in the middle. So in the metaverse, people can feel the space, they can understand how it works, and they can easily be able to put the hand in the pocket to finance physical models once they have lived that reality. For instance, in Africa, we don't have any issue with the sun. So why are you putting concrete everywhere? Meanwhile, even indoors, you can have grass without making any artificial effort for them to grow, for instance. Such are the questions that you develop, and then you see that, okay, the level of humidity is high when you start analyzing. In sometimes when you have big volumes and you are close to tropical forests and stuff like that. But using those natural elements can help reduce that humidity. And maybe you have noticed, or you are a lady, surely you've noticed it. Uh, People that scarf using scarf have the in Africa have the best hair. Once they remove, you see they are long, they are fresh and everything, because there's a level of humidity and heat that is needed to make the hair grow well and in a better condition, and they will not need any products to protect their afro type of hair, and they might not need to relate on artificial hair or whatever, because they will be proud of the results they are having. So when they start analyzing culture, one thing we are even doing is analyzing the scarf. We have put two sensors in the head of two ladies. They are supposed to wear scarf for 1 year for us to analyze that environment, because health is part of the process in designing and everything. Talking of collaboration, obviously the models are available. They can be simulated in various areas and in various countries. We can also start from scratch because we have a process, and we believe with collaboration we will refine the process. We can start working with the office or research lab or contractors, whatever, in Kenya, Ghana, South Africa, provided that they are open to develop large scale, totally reversible projects or recyclable. Imagine a whole city in the metaverse, totally functional, and then you explain to people that that city can be built and last for 100, 200 years, but it's also totally reversible. Means that we can just leave it like that. Tree will grow everywhere, you go elsewhere, and so on and so forth. So it might be a great idea.
It's actually a fantastic idea. Before I get more into materials and the biomimicry and the cell-otrogenesis, the health benefits, there's a debate coming up. You have two fellow architects here asking about how you distinguish. You said you don't like vernacular architecture. You like the term local architecture. Do you use colonialism as the dividing one of the two? How would you define local architecture, especially in the African context as a distinct from other, quote unquote, other types of architecture?
First of all, when you involve in science, but first of all accept the history of the place with his good and the bads, and then try to rename. The wrong thing and the error we have is that we don't have names for things. When you are designing a space, we all went in a modern architectural school, even if it is in Africa, uh, where they will say there's a public space, the private space, the room, the everything. But when you go to a community, you say room. What is a room? They might say the kids' place, the men place, the cattle place. Room means nothing. It's the function that defines and that can help you relate and give a name to the thing. So we come and say that calling it vernacular was a type of description people was giving to say exotic, different, built by maybe poor people or whatever. But if you have to come and discuss with somebody of the architecture in which he's living and tell him that we can reduce your whole village to a skyscraper and you have all that land for farming, how will you no more fight against community? Because your village will be just a building and you have land maybe for 200 years before you increase again, or maybe the population is regulated or whatever. So for me, it's better to say local because local means contextual. It's a location, a specific place in the earth where you have that architecture. There can be similarity from one region to another region, but once you enter and start discussing with them, it's not the same thing. Uh, there's something we do in all our projects, even in the town. We go on the ground, we collect the earth, we go in a lab to know the characteristic to produce maybe blocks and everything. You will see that in a city like Yaoundé, from one district to another, the specificity will change. More so in villages, more so in regions. So it's better to call it local. And then we are producing local 3.0 architectures and maybe 5.0 depending on where the technology bring us. So that's the idea. And it's possible everywhere and everybody can start now.
So then the other part of it is then looking at local architecture, and I'm going to reframe this question in a little bit of a different way. In terms of the values, benefits, and beauty, I fell in love with your village. Everybody talks about the African village, and there you had the modern African village going into a vertical structure. And of course, there's all these debates in architecture about if we use conventional Western architecture, the higher you go in floors, the lower the energy efficiency, just because of the dynamics of how things move. But as the shape and materials that you're using when you presented that African village structure are not what you find in the European or the Western type building design. So have you looked at, in terms of values, benefits, beauty, I fell in love with the beauty of it. But in terms of being able to then cross compare and say, we can actually shift the paradigm of energy dynamics by using local architecture.
Oh, yes, of course. It's something we are trying to analyze to shift from materials we know. We are not even calling it no more Western material or whatever. The material we know as modern citizens and the material that are available that the nature have provided. How can we develop from them? What must we take from the two parts? If I have to use when I have the opportunity, because all clients are different, but when you have the opportunity to use conventional material, try to use it prefabricated and that you can reuse it later. So that all what that will be around is something that can go back to nature or can be reused differently. So it's not simple, but it's an opportunity. That's why we appreciate what we are doing the most, because It gives an opportunity to have competitive industries, competitive manufacturing, and it's part of sustainable architecture because all the time we not have all the opportunity to be like Francis Kere, where all the population will come along to help build physically, but we can develop opportunities for smart investors, for in fact for global funding, people who are funding sustainability, and it will be going increasingly because all the world need to protect, for instance, the forest in the Congo. Everybody is depending on that forest, and Amazonia, everybody is depending. So how can we help those people develop a competitive industry? Is part of the process. So once we go back to becoming architects, meaning that we are no more designing standardized or casual lifestyle for everybody on the earth, but we are designing from scratch. You understand that it gives opportunity to develop new materials, and from the simple approaches to the more complicated ones. With artificial intelligence, for instance, we can study it deeper. With 3D printing, we can study it deeper, process it in a different way, and so on and so forth. So it gives an opportunity to develop new sectors, new opportunities, new materials. And the sense is like nature. Nature never repeats itself. So why are we repeating ourselves?
And on this topic of materials, so Kenya Green Building Society, they're starting their Jenga Green Library, in which it's open to the public, and they're looking for input on different types of materials, alternative construction materials. So that's one immediate type of linkage that can come out of this is figuring out how to collaborate on building that library in terms of architectural. And I want to get more, you describe yourself as an architect and a social engineer, but I also hear you're a biomimetic engineer as you're talking. And one of the things that comes out of ecology is ecosystem niches is one term, and then what they call mutualistic synergy. So, like the bees depend on the flowers, and and what I'm hearing with the whole diversity in cultural population and the diversity in nature, the biodiversity that exists in Africa. There's a unique potential for, instead of
Exactly.
looking at this competition model, we can have, you can have Yaoundé versus Bamenda versus
Yeah.
Nairobi West versus Nairobi South, and there could be a whole architecture just looking at the nature and how that inspires and transforms the building. Can you talk about that?
Yeah, like I say, it's true. I'm a Cameroonian native. I went to school in Cameroon and everything. So it can be the reason why I'm here, but no, it's because we had four geographical areas. Because at first I was trying to shift to Ghana or Nigeria because English part is likely to be more dynamic. But I understood that, yeah, but we have four geographical areas. It means that I can have a much wider experience from here because you have the forest, you have the Saharic part, you have the mountain and everything. So you can at least understand how people try to master all those different places. And when you take the map of Africa, cultural variation is the greatest. Even in terms, we are all called black people, but we are differently black. So even in terms of genetics, the variation is the wildest. Maybe because it's the first continent, I don't know. But in terms of population, of course. But that variety means that competition can really disappear, and then collaboration. Such a thing can give an opportunity to our government, to African Union, to open the frontier barriers because we have everything to share for one another. For instance, there's a type of flower that you will find in the world only in tropical areas that they call, I don't know if in English, I'm sure it's laterite. Uh, yeah, that specific type of ground is found only in Africa, and we are standing on it, but we are still digging it, removing it out to build with something else. So that's an opportunity for everybody in different sector of the built environment. Is really something that we are looking for, and that's why we are not shy. We say, well, yeah, even if it takes time, it's a golden mine. So people have to understand. The thing with global warming, climate change, and everything is, at a certain point, everybody will have to turn back to it. There's no way we can escape finding solution. No way. So we better start now as Africans to prepare our future, and not even only as Africans, because local architecture is found everywhere, and it's a unique opportunity for every place in the world to go back to net zero. All those names they are giving to new architectures have been existing since when people were just being intuitive about their surrounding. So that's why digital tools are important for us, because it will help us go faster in analyzing and in making sure that it works before we start building, maybe in 5 to 10 years.
And that's actually really good about the global relevance of this, because there have been off and on studies that look at things like that. Like, if you study humans all over the world, what do they consider to be the perfect temperature? And it comes down out to be, in terms of it in a room, and it's 70.5 degrees, and then they map out where in places in the world that have a steady state temperature of 70.5 degrees and things like that. So there's the relevance of finding not only the uniqueness and the unique identity and the diversity, but also the similarities that we share across borders, across these boundaries geopolitical boundaries that we've created for
Yeah.
ourselves. In that, looking at health, we were all affected by the COVID-19
Pandemic.
pandemic and the zoonosis. And the zoonosis is part of it is this, what happens sort of in your catastrophic model, where we've depleted nature to the point that we don't realize how much of the health benefits that we get from nature that we've lost until we have a pandemic. But I want to, since there's been so much news about the gloom and doom, I want us to focus on your no worry scenario. So in your no worry scenario, how do we use this digital space to start building the no worry scenario and especially for those who are developers who are like, okay, I have a project right now. I've just watched this broadcast. I was ready to put shovel in the ground. I want to change something before, and I still haven't signed off on the release form, so I can change a little bit of the design. How can we use what you're saying and what you presented to start making incremental change, and then the larger change? How do we use the digital space to start building the larger no worries?
Yeah. Well, every time I say the no worries, everybody will tackle me back with it. But in fact, we have to be able to provide it. So, as a matter of fact, I'm always wondering, why are we in tropical areas living indoors? I don't understand. We don't have snow, we don't have cold winds, we don't have desert sand in most parts. Why are we living indoor? Normally, indoor will just be to protect ourselves against animals. We are civilized folks. We have movement detector equipment nowadays. So if somebody enters, the alarm will ring, he might run, police will notify, and so on and so forth. Why are we living indoors? So if somebody is starting to construct now, the first thing I'll ask him, if it is in the tropical area, wherever in the world, not just in Africa, because tropical is not only Africa, why are you living indoor? That's the first thing. The second thing is because outdoor means you use the void as a material. It's cheaper than to use a physical element as a material. You have the access to natural element more easily because you have that connection. Talking of the issue of health, first of all, COVID opened the mind of many people to get back, and it was already the case, but it was not known that 80% of African population, in fact, in Cameroon, is for sure 80% of people are using traditional medicine, local know-how. And I'm sure in Africa it will be quite the same because we are even not among the countries that are really working towards it. So we will go to Western Africa, it's even legalized. Sometimes it can be used in hospitals and so forth. So that diversities that have been destroyed and transformed into molecules have helped us a lot to improve our global health, to standardize the way we approach everything. But now we have the opportunity to go back to those specialties, those special coffees, those special elements that we can have in our homes. What I provide from scratch now as design, because the no worries has not yet been mastered totally, of course. But what I provide in design is autonomous architecture or habitats. Even if you have just 50 meters square, I must make sure that you have biogas, that you are using your solar energy, that you are using the underground water provided the state accept it, that you are recycling that water, that you have a fish pond, that you have a fresh water, and everything on the same spot. Making sure that some client told me it's as if they're drinking the same water for years. I say, maybe yes, you are recycling it. You too, you are going to the toilet, you are so on and so forth. So that's something that we must urgently go back to because if another pandemic comes now, with the difficulties, the wars, and everything, the lives are becoming more expensive, and so on and so forth, all around the world, not just in Africa. We will have more difficulty to have access to the key elements of our health. One thing that you discover in local architecture or wherever is that the farm is behind the house, the cattle are just beside. Everything is in an ecosystem working all together. And we can start without it being a city at first, at the level of each project. And digging a hole for biogas is not expensive. I'm not talking of any equipment. Uh, Doing a specific water pond, a fish pond, all those stuffs are easy to do because the water you use to water your plants is the water the fish are living in. When you recycle it, it comes back down. So it's very simple. I had a video. I just kept the video showing it because it might have taken a little bit of time. So the first thing I'll ask that person is to make sure that his project is totally uh, working by its own, whether the materials are the good ones or not. But he can provide himself with a little ecosystem where you can make sure that you can have your proteins, your vegetable, and just depend maybe on stuff that need to be grown in big quantity like cereals and so on. So that might be my first answer for that guy.
No, no, no. This is what I mean. That's why I said, what you're presenting could be 2 weeks of unpacking. So,
Yeah,
the last thing I want to ask you, we have about 8 minutes left. You had mentioned this thing of naming, and to give the audience a context, a lot of African languages are relative. And to give an example, in the Luo or the Luo people, which is a part of my genetic heritage, the word tong, Tong, it means egg, it means spear, it means barrier. And it depends
yeah.
on the enunciation of when you're
Mhm.
using it and the context of the conversation that somebody knows. Now, in terms of the global scientific literature, tong needs to be one thing. It needs to be either the egg, the spear, or the barrier. But the truth is that when we're interacting with each other, we're thinking in, like they say, in our native, in the dialect, and in whatever, and that's the culture. So how do we verbalize so that others sometimes misinterpret and say, oh, the knowledge in Africa is not there. It's just, it's not codified. It's not articulated and it's not
Yes,
codified. So what are your thoughts about how to do that?
that's why I say we must start by being humble. to learn from the native, to learn. Me for instance, I know my two native language. I can speak them well, understand, but I've been to school in French and then in English. So when I think in French and I think in English. But when I discuss with every the guys in the village, when I'm discussing with them, I understand that when you try to explain to a kid who grew in a rural area speaking the native tongue all the time, he's better in mathematics than us because due to that language, he has an approach of counting that's so fast and so smart. And maybe it's because he's rooted, I don't know, or intuitive, but I don't. And so it's easy when you are doing workshops. I had an image where you saw us maybe doing it with girls, ladies. We do scarf workshops and recycling workshops, thing with kids because one of my Crystal, co-founder of Chorus, always says that our generation is lost. Better start back in the primary schools, reshaping the minds because we grew up watching some movies and some standards of life. We want all glazings, uh, air cooler and stuff like that because it's part of our social DNA, but we can reshape theirs to be more contextualized. So it's just that it's not codified. It's up to us to do the codification. And then together in panel like this, in discussion like this, each one will try to explain to each other what it means. Science is true, aim to be global, but want to go in the diversity of adapting ourselves like nature, it can no more be global. It needs to be contextualized, and everybody must be able to learn from the others. And in that sense, everybody will become an expert of a specific domain that will help each other. And by then, it'll be easier to develop many industries without some type of competition. I mean.
And that's great because one of the things that, so there were, when I typed that you had a lot of fractals are considered by many advanced mathematics, advanced physics, metaphysics, or things like that. And the belief was that it was Western in terms of origin, but uh, Ron Eglash, who's now at University of Michigan and working with us, he's done a lot of research on this, and he's found that the fractals in African culture, in architecture, in pattern designs and textiles, not only are they uniquely African and did they precede colonialism, but they're highly complex. So if fractals are complex, this is like super complexity. And yet in the designs and paintings and everything, and I was seeing some of the fractal orientations of the buildings, how people just like you were saying that if you go to the boy in the village, he'll count off the top of his head and he has a unique counting system. So one of the things we don't know is how it is people transfer the knowledge of how to make those designs, because what is unique, the reason you know that it's not accidental is when somebody says they're using a particular pattern, even though we have relative language, when they say, I'm going to use this, let's say it's a Dogon, and we're going to build a Taguna hut. That Taguna hut, when you say that, everybody who knows that tradition will just build you one thing. So we have that knowledge, but the number of layers of the roof and the structure, that part is sort of passed mouth to mouth. It's not written in a book anywhere. And what I saw and what you were looking at is the way in which to analyze those layers, analyze those structures, and really start first explaining to yourselves, talk about learning, explaining to ourselves what they are before we can then explain to others and transform them into modern. Any final thoughts on your vision for that?
Yes, there there's obviously many people know about it, at least with the image, the Muslim culture and those Muslim have. When you read, you understand that the high were they could have been comparative to a 3-meter ceiling. Now there could have been 25 floors, but just for one family, a big hole like that to catch up air, and you will try up to understand. That's we say to catch up air, but it's not only for to catch up air. It's to catch up good quality of air because of the surrounding, because of how they themselves they live, because of the type of air they had. To be sure that the highest is go, the better the quality of air is, because it's like a natural filter going up down. But you have to analyze it, to use maybe digital tools, or to live there, or to build with them in difficult conditions for a citizen like me to build with them, to understand the particularities of those different elements. For instance, I come to see that they have, and this is maybe in all those traditional architecture, some more than others because they have the climate is more harsh on them. They have the way what we do, we refresh the indoor air to have the comfortable temperature we want. But what they do, they avoid the bad air to enter. It's two different way of seeing things. So when you see Timbuktu, the Guineas Mount, when you try to analyze, you see that there are similarity with the desert, those desert plants with, don't know the name in English, that's why I'm trying to describe. Uh,
A cactus?
yes, exactly, with cactus. And you see that cactus in the desert, but it's always green because it creates something around that makes air uh, heat to reduce on the surface. And those traditional architectures are reusing those same principles and adapting each other, one to the other, relating to the other. You see in the forest, they'll build with, they'll put sticks and then just put mud on top. We leave holes, and because they have high humidity and heat under the trees, that is totally naturally ventilated from all parts, but with no much light because they don't even have too much light due to the fact that they are under the trees and everything. So when you dig deeper, you understand such principles that are simple to reproduce in with our actual know-how. Let's say like that. So you learn many things by even the layers of the roofs. Why are they choosing this specific material in their milieu? Because they have other opportunities. When you dig deep, you finish by understanding. And we have the chance to have done analytic and analyze how to analyze the building and the construction, everything. So once you go there, you just apply those scientific methodologies. One is difficult, like maybe fractals and everything. You go close to a physician. That's something we do. We are always close to the scientific, the university professors and so of this or that domain to say, okay, we've seen this. It looks like it can be something like this. And something we can do in our result while developing it is to bring other people from other boards that can help us analyze or better understand some maybe forms, natural principles, and everything of the like.
So wrapping up, to get to the no worry scenario, I hear we first of all focus on biomimetics and translating this intangible cultural heritage, the UNESCO term, into codified scientific knowledge. Collaboration, the use of digital tools and the imagination. And with that, as course architecture, what is your vision? What is your vision in terms of moving forward for this, what it is that we need to do?
To move forward, we must first move backward. Uh, I don't know. Let me check something. Okay. Can I share my screen?
Absolutely.
Okay. Thank you. Um, what we are aiming for is the A plus scenario. It's the A plus scenario. We'll just assume that we've been trying to develop, and the edge are always brown, means distraction. To go back to the A plus, we must go to reach the A plus, we must get back to the A scenario. First of all, we must accept that the failure, we accept where we have failed. What people are trying to do in sustainability is that maybe they want to keep the technique and change the material. They want to keep the material and upgrade it. They want to ameliorate the quality of the system they're using for cooling, for heating, and so on and so forth. But when you analyze space architecture, and it's a place where people can go to learn from scratch, because when they say Mars, they just say there's a regolith, there's glass somewhere, and so that's all the knowledge you have. You have to process everything. And I think we can faster process it on Earth than on Mars, and easily, and learn from how we have processed on Earth to go and apply it there later on. So we must get back to the A scenario to find what we need. In our case, we've developed this. We have needs, we have problems, we have solution. To find a solution, you must first of all define a model or a pattern, analyze the pattern, contextualize the pattern, apply the pattern, apply it, and then use it as a new pattern, analyze, and so on and so forth to find the solution for the needs. And that's how we operate. That's what I was talking about. It's like circular economy, autonomous housing. In a simple plot, you must take advantage of all the possibility without destroying the capacity of the plot to relate to the neighboring plots, and so on and so forth. So for me, that's the first thing to do, is to get back to where we were, and then also to develop analytic patterns like this that will help us use any opportunity as a model that should be upgraded from scratch. Because once you think, you start thinking as an architect, you have already preconceived thoughts. That's one of my, one of the things I fight against BIM. Not against, because I don't want us to use it, but because once you focus only on the available technology, you have limitation. We don't have like some raw African materials. We don't have it as family in Revit, for instance. Who will develop it for us if we don't go back to say, okay, we have this type of material, it has these properties, you have this weight, you have this size, and then develop the family that will be used in Revit to have a BIM process of a traditional or a traditionally inspired modern architecture. Yeah.
Thank you so much for that. And with that, we are out of time. And it's been a wonderful session. And you've kept us all engaged. And I'm sure there'll be more opportunities to keep unpacking. And we thank everybody for joining us. Remember that we have another session next Wednesday, same time. Subscribe to the Share Your Green Design channel so you make sure you get the notification. You can keep asking questions in between sessions, and we'll see you next week. Take care, everybody. Thank you.